and welcome back to the channel. This is another very exciting video of our Explainable AI series. It is also the final one on DALEX. In case that you have done any of the previous DALEX videos, you can use the template that I've given you, so that, or the one that you have actually created yourself, because we will be using the same dataset. Again, the first thing that I would like us to do immediately is to install DALEX. So pip install and then DALEX. Here we go, Control Enter. And while it runs, again, we'll be using XGBoost as our main advanced machine learning algorithm. In case that you're interested in learning more about XGBoost, I have what I think to be a fantastic course on Udemy, to which I will also leave the link in the description. On top, in case that you don't have time to code with me, you can also find the link to this template, to this script, below as well in the description, where I'll also share the link to the GitHub. In our tutorial, it's super simple. We'll start with the libraries, we'll prepare the data, we'll run XGBoost, and then we'll have a look at the local interpretability behind DALEX. As a result, so let's continue. Let's open a new cell and let's import DALEX as the X, and then let's also import XGBoost as XGB, and then finally import pandas as PD. And here we go. Let's do Control Enter, and let's also open a new cell. So Control MB. And inside, what I want to do now is to get the data. And the data is actually already inside the DALEX library, which is the Titanic dataset, which is a fairly well-known one. And the idea is that what we'll find is the characteristics of the people that survived Titanic. And what we'll do is that we'll look, or we will zoom in at individual predictions. As a result, so dx dot and then datasets, and then we do load Titanic, and here we go. Let's open the parentheses and let's have a look at our data. So data.head, and here we go, Control Enter, and we can see that we have the gender, the age, and then we have survived. So this is our dependent variable, but we have a lot of strings here. This is something that we'll do now that will kick our data preparation stage. And what we'll do is that we'll transform all of these variables into dummy ones. As a result, let's do transform into dummies as a comment. And inside, what we'll do, so data equals to, use pandas and use the function get dummies. And then inside this function, there's just two things that I want to include. The first one is data, and then the dropped first, which is optional, but I would highly advise. And this is so that we don't fall into the dummy variable trap. Again, Control Enter, let's open a new cell. And then here, what we'll do is that we'll isolate X and Y. And this is to prepare and set the stage in order to create an XGBoost matrix. So let's start with a Y, and the Y equals to data dot survived. And then the next one is X, which is to our data without survive. So data, and then we do drop, and then inside we include columns equals to, and then we just in single quotes survived. And this is just that. So let's do Control Enter again. Let's open a new cell and let's create the XGBoost matrix. And how to do this? So we'll call it train, and then use the XGB library, so XGBoost dot, and then create this D matrix, and then inside we include our X, and then we specify our label, which is the dependent variable. So label equals Y. Again, Control Enter, and now it's finally that we go to the XGBoost stage. Let's open a new cell with Control MB, and then here we'll create the parameters. We need to specify them because we are doing a classification problem, and XGBoost by default is using regression. And as such, because XGBoost cannot tell between a regression and classification if it is not being told to, then we need to specify it. So params, and then we open a dictionary, we create this objective, and then on the right of the quotes, colon, and then quotes again, and then binary, colon, and then logistic. This is the one that will include, and then comma, and then eval metric inside the quotes, and here we go, and then on the right, colon, and then we'll specify the AUC because this is a fairly balanced data. If it was not, then we would have used the F-score. And here we go. So let's do Control Enter, and let me open another cell, because now it is finally time that we do the XGBoost model. And we'll keep it super simple. So let's create our model. So model equals 2, and then use the XGB.train function, and then inside we include the params, and then we include the train. Here we go. Control Enter, it has run. And now let's open a cell, and what we need to create is this explainer object. For those who have watched the previous DALEX one, this is a different one, because since we'll be explaining individual predictions, we also in a way need to predict. And this is what this explainer object will be different from the previous. So the x.explainer, so this is what we need to do. And then inside, again, the model, the x, and then the y. But now it is different because we now need to specify this predict function. So predict function, and then inside, so equals to, and this is what we need to do. So we include this lambda m, because this will be a function, and then a comma, and then we use d equals to, or d colon, and then m dot predict, and then we predict from our XGB dot d matrix. And then inside the d matrix, we include the d. From the perspective of having to change this, or for replication, you don't actually need to create anything, because this works as a dummy function that can work regardless of what you have. So as long as you include your model, your x and your y, this is just what you need to create. So here we go, and let's do Control Enter, or rather yet Shift Enter, so that we also open a new cell. And you can see that it has been initiated. And then here we look at the local interpretability. And what can we do? So let's as well, and let me open a new cell here. So x.head, and here we go, so that I can also look at some of them. And here we go. So if I am to explain, for instance, explainer, and then dot predict, and then parts, and then I open, and then here I include my x, and then I specify some. So I lock, and then here I could, for instance, try to explain the third one, so index 4. And here, so 4, and then comma, and then colon, because I want to talk about all of the columns, or all the predictors. And then I just use dot plot, and if I use just dot plot, this is what will happen. And here, and what we have here is this waterfall. So this is how much each of the variables is contributing. And what you need to understand is that we have this intercept, which is this average response. So this is, if we don't have any of these drivers, this would have been the average prediction, which is also the mean average of the amount of people that survived. And here you'd see how each of them is contributing. And I find this to be actually really good for presenting to other stakeholders, because here you can really pinpoint, based on a certain prediction, how it would fare. And I think that for explaining what your model is doing, to be such a fantastic technique. As a result, I hope that you are as amazed as me by this DALEX package. This is the last video that I'm covering, at least for the time being. I'm really hoping to see you soon in another video, and until then, have fun!